Hey everybody, today is the last video for this unit and we're going to be looking at just a couple of proofs. Just a reminder, your quiz is going to be this Friday. We're going to save this warm-up for class tomorrow. So if you want to just open up to page 36, go to the bottom and we'll talk about this proof. So let's see what they gave us. Remember, you want to give statements, can't assume anything, and then the reason that you gave me that statement. So it tells us this is a rectangle. It tells us XB is congruent to AZ. And 1 and 2 are both given. So XB from here to here is the same as AZ. Okay? Now, we're trying to prove that WB, and I'm not marking it as congruent because we haven't proved it yet. This is what we're trying to prove, is the same as this. So what I need you to notice is you have two right triangles here. So if we prove that they're congruent, we can prove that their parts are congruent by CPCTC. If you weren't here for the proofs unit, we'll talk about what that means. So let's address this rectangle. All right, that tells us a lot. So first of all, we can also say that WXYZ is a parallelogram because every single rectangle is a parallelogram. So all rectangles are parallelograms. You could write out the word too if you'd like. All right, so since it's a parallelogram, we know that XW and YZ are congruent. And the reason that we know that is because of definition of a parallelogram. Opposite sides are congruent in a parallelogram. All right, so based on what we have so far, if you look at this triangle, let me try and shade it in a little bit. So if we just look at this triangle right here, it's not going to work for me. Let's try it again. So if we just focus on this triangle and this triangle being congruent, we'll be all set. Now, we could say that X and Z are, angle X and angle Z are right, but we don't even have to say that. We can just say that they're congruent because opposite angles are also congruent. Not only are opposite sides congruent, but opposite angles are congruent. So for number 5, I'm just going to say angle X is congruent to angle Z, and the reason opposite angles are congruent in a parallelogram. All right, it's all part of what a parallelogram is. So now we've shown that angle X is congruent to angle Z. I mean, you could have gone further and said that they were right angles and all right angles are congruent, but you don't need to do that. Now, if you look, we have side, angle, side. So we can say triangle, I guess I'll say BWX is congruent to triangle. Since I started at B, it's going to be AYZ. And the reason, side angle side. So now for our last step, we can say WB, which whatever it tells you to prove, always your last step. So side WB is congruent to side YA, and the reason, corresponding parts of congruent triangles are congruent, or CPCTC. Okay? All right, so let's look at one more, a little more complicated. So I put all your givens here, so 1, 2, and 3 are all given. And again, once in a while these will show up on the regions too, but a lot of times it's going to be those coordinate proofs we've been working with. Okay, so first of all, because PROE is a rhombus, we know that all 4 sides are congruent. All right, we'll deal with that in just a minute. All right, the next, we got to see what we're trying to prove. It then gives us, it tells us these are lines. That really is just telling us they're straight lines, not anything you're going to use. Angle SPR. So this whole angle is congruent to angle VOR, this whole angle. All right. And we're trying to prove that SE is congruent to EV. So if we first prove that these two triangles are congruent, then we can prove that their parts are congruent. And if you look, we almost already have a side, right? So let's work on this. So we can say, all the sides are congruent, yes, because they're a rhombus, but we can also say that just side PE is congruent to side OE. And you can say definition of a rhombus. Just remember, a rhombus is like just kind of a smush square. You could say all sides are congruent in a rhombus. Just mention the rhombus, okay, and the sides. So now we got to deal with the angles. First of all, I see a freebie right here. I know that angle 1 is congruent to angle 2 because they're vertical. So angle 1 is congruent to angle 2, and the reason, vertical angles are congruent. Okay, so we have a side, we have an angle. Now we don't have any other sides that we can work with, but what we do have are these two angles. Now, that's the whole thing. We need to get inside of here. So the first thing I'm going to do is say, because remember, a rhombus is a parallelogram. So I'm going to say PROE. Oh my gosh, that's PROE. Is a parallelogram. And the reason, rhombus are parallelograms. Okay? So then I can say angle, we already used 1 and 2. We'll say 3 and 4. We don't want to say 1 and 2 or just angle P and O, because there's more than one angle at P and O. So now I can say angle 3 is congruent to angle 4 because opposite angles in a parallelogram are congruent. Now, the thing is, we didn't find these angles yet, but since we know that this whole angle is the same as this whole angle, and this angle is the same as this, if I take this big part and subtract angle 3, it's the same as taking the big part and subtracting angle 4, and you'll get inside of that triangle. So I'm going to say I'm taking angle SRP, and I'm subtracting angles 3 and 4 from it. So angle SPR minus angle 3 is congruent to angle VOR minus angle 4. And that's just subtraction. Sorry, that's sloppy. So again, I'm just saying angle SPR minus angle 3 right here is the same as taking angle VOR and subtracting angle 4. And what we're left with is angle 5 being congruent to angle 6. And then we can prove that the true triangles are congruent by angle side angle. So we're almost done. So when we actually subtract those, angle 5 is congruent to angle 6. And again, I'm using angle 5 and 6 instead of saying angle SPE and angle VOE. All right, if you just label each one clearly, you can do that. That's a 6, by the way. All right, and that was just simplifying. That's what you get when you subtract the other two. And so our two triangles are congruent. Triangle, let's say ESP, is congruent to triangle EVO. And that is by, if you follow the picture, angle, side angle. And then we can prove that these two parts are congruent, because if these two triangles are congruent, any matching parts are. So your very last statement is always what it wants you to prove. SE is congruent to EV. Because we just proved that two triangles are congruent, we can say corresponding, or that's the same as matching, corresponding parts of congruent triangles are congruent. Okay, we'll stop there. We'll do more practice with this. You will not have one of these on the quiz on Friday. Have a great day. Stop in if you have questions.